time the next couple of weeks. So, and recording's on. So, good afternoon, everyone. Welcome to the Thursday, April 17th edition of the HamSCIence Zoom call. We've been spending a lot of time the last couple of weeks, very fruitfully, discussing the meteor scatter events that we'll be holding in July and in August and December. Just want to remind everyone of the Lyrid shower this weekend. There's definitely an opportunity to get on to either transmit and or receive and send some data to PSK reporter. I'm pretty sure I'll be listening on 10 meters, at least, yeah, Friday, Saturday, and Sunday morning this weekend. So I'm going to give it a go. But not to hold things up, I would like to turn it over to our guest speaker, Dr. Peter Hall, who has very graciously agreed to speak from his home 12 hours ahead of us down in Australia with a very interesting presentation on that I originally got caught wind of in QEX, the Experimenters magazine from the league, and I contacted Peter and he graciously agreed to appear. So, Peter, if you want to get started, we'll let you get going.
Well, thank you, Gary, and good afternoon to everyone. Thank you for coming along. And um, also, I've been a sort of admirer from afar of HamSCIence, and I thank you all for the invitation and the opportunity to speak to you this afternoon. So the title of my presentation is a contemporary LF-MF ham station, and in some ways it's a bit cheeky because you can't change the laws of physics, and LF and MF are no more or less difficult in fundamentals than they ever were. But I hope that perhaps I can show you that there are, by taking a somewhat more contemporary approach to the design of a station, you can make it a bit more palatable, that you don't have to suffer as much as you traditionally have to get on the LF bands. So what I'm going to do today is to just talk about my motivation for building an LF and MF station, and to talk a little bit about that station. And I'm going to just focus a bit on LF, low frequency, for brevity, because just about everything you engineer for that spills over into an MF or medium frequency application as well. So I'm talking about LF, but I really mean LF, MF in most cases. And I'm going to make it a rather technology focused, just give you an idea of what the technology of the station looks like. Talk about some of the first outcomes from the station, and just to give a bit of a flavor of the future directions, including some of the science directions. My career has been in radio astronomy, and most recently I've been a professor of radio astronomy engineering at Curtin University here in Perth. So I'm quite interested in directions for the station that involve science and engineering research, and particularly student projects and so on. So I guess everyone knows what we're talking about, but just to make sure our terminology is understood, I put some extracts here. It's from the Australian spectrum plan, but I guess the US one would look very similar. Certainly for the MF and LF bands, 136 kilohertz and 475 kilohertz, and it's sometimes forgotten that officially actually 160 meters is an MF band. And I guess historically, as I understand it from the very old literature, it's MF is the MFHS transition has to do with where the ground wave was commercially viable. So we're talking here some quite small radiated powers, as you can see. The struggle that I'll be describing this morning or this afternoon for you is all to get 1 watt EIRP on this tiny little segment of spectrum down at 136 kilohertz. It's a little bit more generous at MF, where you're allowed 5 watts EIRP in both Australia and the US. Once you get up to 160 meters, you're in the realm of the normal power limits that we're all familiar with for HF. So I guess just to talk a little bit about my own motivation, and I guess I have to come clean and say, well, after a lifetime in low noise receivers, probably up to sub-millimeter receivers in frequency, hundreds of gigahertz and so on, I thought I'd just perhaps it was a subconscious switch that drove me to low frequency transmitters. I didn't know much about those, so I thought, well, I saw some interesting results, so I thought, why not? And it turns out the technology is very interesting. You're dealing with antennas that are really only just beyond lumped element circuits. The radiation is almost incidental, shall I say. Um, I also noticed there were a few people dealing with some interesting signaling experiments involving transferring information at almost the limits for the channel and so on, which I found quite interesting. And I suppose some of you may know the community and MF-LF community, and it's a very experimental based community, a lot of hands-on work. Mainly because traditionally you've had to in order to get by on those bands. And of course, we all are fascinated by propagation and some of the radio science of the magnetosphere and so on that goes with that. So I found LF interesting because the descriptions were not clean on on how one might characterize the propagation. VLF is undoubtedly ground wave waveguide modes and so on, and MF and HF are traditionally described with RAID type propagation models, but LF is this kind of horrible mixture, and I thought that was rather interesting. I noticed there was lots of history, of course, because the commercial LF broadcasting's been around forever. But there's also a lot of new work involving new tools for probing and modeling the propagation. So I thought that tied up well with some of my admittedly peripheral, but still I'd say interests. Incidentally, I tried going to US spelling through the whole thing, and although I write all my IEEE articles and so on quite happily, I seem to make a mess. So you're going to have to deal with the odd double L and S instead of Z, etc. this morning. Um, another thing I noticed was that Western Australia, VK6, was a complete void in the LF transmitting and receiving coverage. We don't actually in Australia have any LF broadcasting. We do actually in Western Australia have a VLF military transmitter at Northwest Cape, which is a joint US Australian base. So lots of work, of course, on VLF propagation and navigation and so forth. But I thought that I didn't like seeing the hole in the map when I looked at the WhisperNet map on 4LF, and I thought we could do something about that. There are some challenges in doing something about that. These wavelengths, of course, are very long. 2.2 kilometers is pretty big, and it's quite challenging often to get those sort of wavelengths being radiated from a suburban setting. Still, it's worth bearing in mind that even if you've got towers that are, the 50, 100-meter variety, they're still quite small electrically on these bands. So it seemed to me that to make some sort of international impact and to allow some of the propagation and radio science and ham activities to proceed, that it made sense to try and get a remote station going. For me, at least, as a city dweller. But of course, there are plenty of people around on these bands who have a bit more space and are able to do quite effective transmitters from their own property. And of course, plenty of people can make efficient receive antennas from suburban lots and so on. So remote is interesting and appropriate for my application, but it's by no means the only way to get on LF and MF. And I just wanted to make the point too. People hear about the X non-directional beacon, decommissioned non-directional beacon that is the basis of my VK6 MJM station. But actually, that antenna is only, in your terms, 73 feet or so. And so that's quite comparable, of course, with many ham installations. So it's it's a different way of devoting your hardware, uh, but it's not outrageously large or anything like that. So if I look at, I'm a relative newcomer, by the way, to a LF and MF. About perhaps about 5 years around, and if I looked at the bands, I saw that they were very interesting in that, as I mentioned earlier, they were very experiment and innovation rich. Uh, and it is still true that although it is handy to have a healthy credit card, you can't just take a credit card into a store and get on LF at least easily, and even MF would be hard. But I did notice that there was a lot of interest in anomalous propagation, which, rare DX, and we can with modern equipment and modern signaling modes such as the high duration, low bandwidth JT modes like the FST4W and so on, we can actually make a pretty good contribution to some of that. And actually, in terms of propagation to and from Australia, I think it's true to say that the BK6 MJM results are already quite interesting and a little bit unexpected in some ways. But it's the good news is that you can generate the signal and receive the signal now with much more ease than at any time in the past, because although it's not actually completely universal, it's fairly common to be able to go and buy a transceiver that will produce a transmitter drive signal and have a pretty good receiver. And in fact, in my case, I just use a Kenwood TS590, which is not by any means an elaborate transceiver. It's also possible now that a lot of nice active antennas around, small loops and so on to build and buy, active arrays that are both analog and digital signal processing and so on. So if you're a receive only station, for example, and you'd like to get on the air quickly, there are options without necessarily having to make a very large construction project. Quite importantly, I'd say, is the power amplifier scene, the nonlinear class D and E amplifiers that we often use for these modes, digital modes and CW on LF and MF. It's pretty easy to homebrew them. They do have a theory of their own and an understanding that you need to have to do it well. But I'd say that antenna current has never been cheaper. So these things look very much like your typical switching power supply. And it's relatively easy to get higher power than in the past. And that means that you're a little bit less worried about efficiency in your system in terms of queues of very large loading coils and things like that. You'll never find me arguing against efficiency, by the way, but it just means that the situation is relaxed a little bit. If your loading coil queue is 300 or 400 instead of 700 or 800, that's all doable. The mathematics work out reasonably okay in order to achieve the allowable EIRPs. And of course, I guess many of you folks are quite aware that there's never been a better time really for hams to get access to good metrology and test equipment and so on. And so things like um, putting the system together, tuning the antenna, monitoring the transmissions, and so on. It's not trivial now, but it's a lot easier than it used to be. I still have an RF current meter, but I don't need to have bridges and things to tune the antenna routinely. A VNA or a vector antenna analyzer is the tool of choice for the routine daily and hourly tuning. And I shouldn't forget the software as well. It's great to have the computational electromagnetics that we all have access to now. Um, we that remote station that I talked about earlier is easier to operate than ever. We don't need a lot of specialized software. Remote desktops such as AnyDesk, TeamViewer, and lots of other things uh, work extremely well. So basically, if you can get the station computerized, you've got the station remotized. um, and while I certainly have nothing against custom software development, we all have our limited amounts of time to spend on radio, and we all have our preferences on how we spend the time. So if you're not a software person, it's just kind of interesting to note that you don't need to write scads of custom software in order to make all of this stuff computerized and by extension remotized. So if you are a software person, of course, the world is your oyster, and talk to me later. So just a word, I think, about the station, VK6MJM. It is a reborn NDB. It's a decommissioned NDB, and the ident of that was MJM. So that's where the station call sign comes from. I mentioned earlier it's a 74-foot umbrella-loaded antenna. It's an insulated tower antenna. 3.7 electrical degrees on 136 kilohertz. So not much radiation resistance there, about 0.07 of an ohm. Very interestingly, I thought the radio gods were with me here when I measured the self-resonant frequency of the top-loaded antenna at about 1800 kilohertz. So someone's telling me to get on 160 meters there. The radial field of the monopole is a bit unknown and possibly a little bit fraught. Actually, we suspect there's been some damage over the years, but I'm guessing that it was originally 22.5 meter radials. What did make this particular site attractive was that it came with some infrastructure, very tiny amount of infrastructure in absolute terms, but a good quality steel shack, air conditioned, workbench, power, etc. It also had a functional antenna coupler or tuner, which I'll talk about shortly, near the antenna, which got me on the air in the short term. But just last week, I commissioned a new homebrew wireless controlled coupler, which I'll talk a little bit about as we go on. And as I mentioned, been mentioning, in fact, both the transmit and receive operation of the station is via the internet and remote desktop arrangement. So where is it? I guess I can start by saying, we're about here, the southwest of Western Australia. So you can see where the 12 hours comes from here if you look at the longitudes involved. So we're down in this little corner. The capital city of Western Australia is Perth. And if you look at the map that's covered over on my screen, but it's a blow up of that little square showing that the town is a place called Manjimup, which means various things to various people in the Aboriginal dialects, but there's some consensus that it means a meeting place near water, rivers and so forth. But it's a town of about 10,000 people, about 3.5 hours drive from the capital city of Perth, on the edge of town. The town is sort of the conurbation is over in this area, and it's about a kilometre or two on the edge of town in an open field. And in fact, the bit I haven't shown is that it's on the extended centre line of the runway for the airport. It served as something of a locator, a beacon there. And just for this audience, I couldn't resist the standard area metric of Texas's. So WA is a pretty big place. It's about four times Texas, a little less. So the remote thing is all well and good, but you don't want to be too remote. But you have to be remote enough that first of all, you can find a site. Second, you'd really like, having gone to all that trouble, you'd like to find an RFI quiet place. You don't want to get to the middle of nowhere and have your neighbour's solar power system next door blow you out of the water on receive. So fortunately, the radio gods were fairly kind in bringing things together for me at this location about 3.5 hours from Perth. So just to give you an idea, I mentioned I'd been around this for about 5 years. It's actually more like 6. And like all good projects, it's the site that delays you and costs you more than you thought it would be. But I did have the excuse starting in July 2019 that somewhere in the middle of that we had a nasty epidemic to deal with. So things didn't really get started until about February of 2022, when I got a site license for the site from the local shire or council. So really, it's about 3 years of trials, first operation, and to get to where we are now. We did have a month out with some surge damage. I mentioned lightning. It wasn't anything on the RF side, actually. It's not an uncommon story that the surge actually propagated in the shack via the USB system. So that cost a month. But anyway, so I'd say about 3 years of serious development at perhaps I guess I don't know what you folks have in your way of radio allocation, but perhaps mine's about 0.1 to 0.2 FTE. And I'm not quite sure I'm the FTE I used to be either, but it's something of that order anyway. Okay, so there were a few decisions I made initially, and one I've been touching on quite a bit was the both transmit and receive operation. I was very conscious that either a transmit beacon or a receive only station would be very, very valuable, but not as valuable and not as much of a service to other stations around the world as a TR operation. And that sort of imposed, a few constraints at the outset, like use of mains power and a great effort to keep the RFI at the site low through the development, etc. I wanted it to be continuous as far as possible, so that meant that I really did have to look at running the air conditioner in the shack, etc. And I also wanted it to be a very effective station on the long duration digital modes, the FST4W 1800 and so on. So that put some constraints in on signaling fidelity, transceiver stability, and so on, that push me towards the use of a local PC and transceiver at the site, which fitted well with the remote desktop control idea. So I also mentioned that it was pretty much radio technology driven, but I've done enough software to make the choices that of hardware and associated systems that you don't make the software, the customized software, any more difficult than it has to be to bring online. So at the moment, it's all third-party commercial software, but the day will come when it has much more friendly integrated software package. And I'm not a patient person. I wanted to fast track this as much as possible, consistent with my FTE allocation, which meant reinventing as few wheels as possible. Although I must admit, I invented more than I thought I was going to have to. So that was kind of a learning experience that we all go through on every project, I think. My general approach has been to produce very reliable hardware, polished to a degree, what I call the installable prototype level, with documentation, because I've known over the years what lack of documentation can do, but functional documentation rather than exceptionally extensive. Okay, so what does it look like? Well, here's the antenna, the 22.5 meters, 73 foot, I think, tower. These there are 6 top loading wires here, the umbrella loading wires, and they're about I think about 20 feet. Yeah, 6 meters or so each one. So, whoops. So it's the antenna capacitance is about 600 picofarads, which is not vast for this type of station, but enough to be effective. As I mentioned, an insulated base live mast arrangement with a single porcelain insulator and the radial field going out from the corona shield and so on around the base here. Actually, we don't run this much power normally, but I thought the ionized sky around the antenna was a good PR bit, but probably not to the Spectrum Management Authority, of course. It's just a pretty picture that I happen to like, and I haven't been able to get anyone to publish it yet, so I thought, why not? The I mentioned the antenna coupler, and I'm going to talk couplers for a minute or two shortly, but this is what the new coupler arrangement that I installed last week looks like. It's an antenna tuner based on a large box that contains a loading coil and variable loading coil, in fact, and impedance transformer. And then that gets you on MF. If you want to go to LF, you need another 2 and a bit millihenries of loading inductance, and that's this big guy here. This is a 206 litre low density polyethylene bin. 206 litre, I guess, must be about 50 gallons, and so it's quite big and quite fun to wind and dope, etc. The workshop still smells like methylated spirits and various dopant agents dissolved in that. So that was quite a thing mechanically as well as electrically. And I just guess I should talk a little bit more about the loading and tuning, because it's a little bit different than most people know about with their HF systems, but not so different in principle, with these very short, electrically short antennas, highly capacitive. The standard way of tuning them and having it accept power from your transmitter is to provide a loading coil which provides an equal magnitude opposite sign reactance in the form of an inductance. And because of weather effects and so forth, it's advantageous to make at least a section of that inductance variable, often in a thing called a variometer. Typically, there's a means of measuring the RF current, because that's that's the metric in these very short antennas as to how well you're exciting the antenna and how well it's going to radiate. And then the usual sort of tapped toroidal transformer very often to translate the antenna resistance um, at resonance into a 50 ohm circuit. So it's a relatively simple thing in theory, but the practice gets uh, a bit challenging when you come to the size of the components involved. Okay, so what are some of those components? Well, I thought I'd just put this little equivalent circuit up to give you a feel for the sort of numbers that we deal with and the sort of challenges that are around the antenna. This is actually the VK6 MJM mast at 136 kilohertz with a current of about 2.2 amps RMS, giving, as it turns out, about the 1 watt EIRP limit. So the first thing, as I said, modeling and or calculation will show you that the radiation resistance of the antenna is about 0.07 ohm, which is pretty darn small when you compare it to the ground resistance, which is about 8 or 9 ohms, the structural resistance, which is probably about an ohm, and the big coil that we have some close-up pictures of later has a Q of about 370 or something, which gives you an effective AC resistance of about 5 ohms. So you can see where we're going here. The antenna resistance where at resonance, when the coil and the capacitor, the antenna capacitance reactance are equal in magnitude, is going to be about 15 ohms. But of that 15 ohms, we have a pretty small radiation component. So it comes out to about 0.5% or so efficiency there. So that sounds pretty bad, but actually, if you think about it, particularly with this antenna and with the modern amplifiers and so on that I mentioned, you can work out that for your putting in the monopole directivity factor of about 3, when you're radiating a watt EIRP, you'll be radiating about a third of a watt from the tower. And you can work backwards with that third of a watt and the antenna efficiency to figure that you're going to need about 70 watts into the tower to get your 1 watt EIRP. Now, that's actually, whilst it doesn't look anything to dance in the streets about, it's actually pretty good for an LF station, amateur station. There are plenty of people have quite effective stations, but never actually managed to get to the 1 watt EIRP with any sort of reasonable power. So not too bad a result, but still the old caveats around LF apply. If you look at the voltage drop across the reactance, for example, you're looking at 4 kilovolts or so RMS or more than 5 kilovolts peak on what is actually a pretty benign LF system. If you're doing this in the backyard at home with a shorter antenna, etc., you can easily end up with 20 kV or something at this point, and you need to take the appropriate insulation and safety measures in these systems. So what does it look like? Well, just to give you a very quick idea of how it all fits together, there's very little. Well, actually, there's probably almost nothing now of the NDB left, except the live mast antenna. But as I mentioned, I use a Kenwood transceiver, which is one of the transceivers that allow both LF and MF signaling at the 0 dBm or milliwatt level. Some class D amplifiers that to about the 300 watt margin, with some protection for overcurrent and reverse power, etc. All of the usual things that we build into our designs. This is actually most of this amplifier comes from David G0 MRF, I might say, with a fair amount of modification to the drive circuitry by me. The station really has two modes actually, and that's the mode, of course, is controlled remotely. The run mode just runs the power through the system through a wave node power meter, which is one of the few power meters that works well at LF, um, into the antenna via some buried RG213 and the coupler over in the right hand side here. The coupler looking very much, of course, like the schematic that I showed earlier, except that in practice, it doesn't have all the usual manual controls or underground cables and so on, but it's based on a 2.4 gigahertz Wi-Fi link from the station computer. So there's complete galvanic isolation in the control of the coupler. The other mode is the tune mode, and that's when that's selected. I use a vector antenna analyzer to provide the tuning curve of the antenna, which I then use in association with the remote coupler control to tune the antenna from my desktop. So that's roughly how it works. There are a few twists in the whole thing, of course. It turns out that grounding and so on is very critical, not just from the safety point of view, but from the point of view of getting low noise receive operation, and also low or good carrier to noise ratio on the class D and E amplifiers. And I found the isolation transformer here helps enormously in both of those regards. So pretty simple in principle, and it works effectively. There are a few things I would probably do a little differently in the physical implementation, but the conceptual design works pretty well. I'm not going to dwell much on this diagram. This is the new integrated Internet of Things antenna coupler that I've been talking about, where you have the traditional RF path at the top here, loading coils, variometer, in this case an RF current probe, a normal current transformer type probe, and the toroidal transformer tap being selectable via a power relay box. And the whole thing's actually driven by an IoT controller module made by a Bulgarian firm. Pretty nice engineering for the sort of prices that are involved. Driving some control relay boards and some A to D buffers and that sort of thing. I mentioned the galvanic isolation, which is a big thing in this system. Certainly after the experience that I had last year with the month's outage, with the surge damage in the IT area. This sort of controller gives you a lot of flexibility in use, and also for extension. It's I think if you look at the commercial LF beacon and similar manufacturing companies, they will have a thing they'll call an auto coupler, but they're typically nowhere near as flexible as this sort of arrangement, and they're importantly for this use, they're nowhere nearly as well engineered from the two-way EMC point of view, and that's quite important, because when you transmit, it's quite, this thing sits near the tower. It's quite possible to kill off the Wi-Fi link with overload from the LF, for example, and perhaps even more worryingly, that sort of thing we're all used to sorting out. Getting the grounding right was actually the key there. But the thing that you can see what can happen here, you've got this current transformer going into a digital box. It's just an ideal way of killing your receiver from its effective sensitivity point of view. So it's took a little bit of thinking to, how this could be done, and a little bit of tweaking on the final design, but actually it has very good EMC characteristics in both directions. So that has worked out quite well. Vacuum relays just select the two bands. By the way, you can bridge out the final 2.3 millihenry loading coil to operate on MF if you want to, and you just then have the variometer as a single tuning coil for MF. All right, so enough talk. Let's just have a quick look at some of the sort of systems. This is the rack in the little steel shack. Oops, it's we've got the TS 590 receiver, a transceiver in the rack here, with the homebrew power amplifier arrangement at the top. The power amplifier actually does have a little Zactec standby whisper exciter that can just drive that box alone, can be the station transmitter on LF and MF if you just want it to run as a transmit beacon with whisper. The top is the antenna controller box that does all the switching between the run and the tune modes and so on. The power amplifiers, there's a fair amount of air and cooling thought gone into air circulation, cooling arrangements and so forth. And these Class D amplifiers run pretty cool. The other pictures are of the coupler controller, the digital controller, and the relay interface. I can't actually see the coil on the top on my screen here because I'm showing the sidebar on the conference, but perhaps you guys can see the 2.3 millihenry coil there. That's in test in my backyard actually, and the coupler current probe here, which, as I said, is the standard current transformer type. Just on the amplifiers, I mentioned they look a lot like power converters. Well, this is a picture of one here. And this is a little drive modification that I came up with to get around the usual way of driving these push-pull amplifiers with doublers and dividers to get symmetrical square waves at the operating frequency. I found that seems like a lot of work, and I'm a lazy person. So you can actually get a very nice low phase noise system with this sort of circuit involving a fast comparator, and that works very well. So the sort of remote screens, I won't go into all the detail here, but this was one I produced very recently, yesterday, I think, with just showing the tuning curves of the antenna as I step through the various antenna resistance settings in the relay box and vary the tuning variometer either side of the nominal 137.4 kilohertz operating frequency. We're dealing with some pretty small bandwidths, 2-to-1 SWR bandwidths of about 500 hertz. But it all behaves pretty benignly, and the coupler performance is quite nominal. So I've been quite happy with that. And tuned up, we get very good results on good days. It's sort of 40 dB return loss. On it's a bad day if I have to take less than 30. So it does work very well with particularly with the new remote tuning. Okay, so where have we got to? And again, I'm not going to go through all of the results the station has, except to say that the goal of doing good digital signaling has been met, and as of last week, we're doing good 4W900, and in test conditions at least 4W1800 transmission. So the new coupler gets rid of a limitation that involved overheating of the previous, I think, damaged Litz coil in the old coupler, the NDB coupler, and we no longer have any real effective key down time limit on the station, which is very, very good after working around the previous damage issue, which I think was probably due to one of the aeronautical technicians partially scoring the Litz bundle at a few points with a drop screwdriver, I suspect. So the field strengths are pretty good, measured at 475, very, very close to nominal. Was quite interesting when I put the station on the air on 136 kilohertz. A few weeks later, we managed to set a record for Oceania to North America, and I didn't know it at the time, but we've done that many times since, and it's been good to see 136 spots from the US right up into Alaska. Just last week, there were some new stations came along with the 4W900 mode, and it looks like that's going to be a very interesting mode to pursue. We do well on receive. That's quite interesting. Most people don't give you much encouragement to use a monopole as a receive antenna, but it all depends where the monopole is. Uh, and so we've been doing very well with receive from Europe and Japan. Not too long ago, we had a good spot of G3 SDG, which was nice for him and nice for me. It was a good thing. And I hope, of course, as the sun quietens down a little bit, that there'll be a little bit more of the long distance DX. Well, I don't want to talk about propagation because we'd be here forever, but I've been extremely impressed at what I've learned in terms of the seasonal propagation around the site. I think it would have been quite wrong to look at other propagation around the world and try and map it onto this southern hemisphere site where we routinely have trans-equatorial propagation. So there's been a number of things I've learned in terms of the importance of time resolution and so on in the signaling that stay with me. I think the challenge now is to go from anecdote into data. And there has been quite a lot of activity here in VK6, one arising from the VK6 MJM effort. One of my colleagues here in Perth lives in the Perth Hills and has just built himself a two-tower Marconi T flat top antenna. So with parameters that are going to really give VK6 MJM quite a run for its money, which is great. Okay, I'll just mention the headlines of where I think we might go with some of the education work on the antenna. I think obviously the propagation, we keep coming to that, and not just the radio side of it. The visualization, of course, is very important, and there's a lot that one can draw on there from other work, but there's it's not possible to get a complete 24/7 operation, and with only a few stations, you're necessarily sampling the parameter space fairly lightly. But we can do a lot better than we have, and I think that better visualization will certainly help there. I think I've been talking a lot about power amplifiers, and I like reading the literature and learning on from the professional and amateur literature on the class about class D, E, and other designs, but I'm pretty sure there's more to learn, particularly in things like the effect of load matching, not just on efficiency that everyone focuses on, but things like carrier to noise ratio and so forth. A bit of some idle hours in a near field probe, you learn more than you ever wanted to know about your system. And I mentioned the uh, the system, the communication signaling at near the theoretical limits. I think that's something that I think a lot of students would find challenging and interesting. So where are we going? I think first of all, I mentioned that the monopole has been doing better than anyone ever thought as a receive antenna, but that doesn't mean we can't improve it. And I think having some really decent receive antennas on site will give us dividends. The software I've talked about. Of course, the thing will work very well on HF and 160 meters, and that's something of a priority for me. The new coupler is designed to be able to bypass the exotic modes and insert an HF auto tuner in the box to use it as a standard HF vertical. Other things we've mentioned, the I, I think the simultaneous signaling modes actually is something that that fascinates me. The story has not been completely written on the which modes work best under what conditions on what sites. And really, the only way to resolve that, with particularly as we've got a fairly small cohort of interested people, is to be able to transmit various modes simultaneously, and that will push me ultimately to having a linear amplifier online, possibly not for routine use, but at least available. And of course, it is a pretty nice site from the infrastructure and radio quietness point of view. So I am looking at the idea of something like a Kiwi on the site. So I guess that's my story. I hope that it has elements of interest at least, and might provide some ideas for people interested in doing uh, similar projects. Possibly no one's going to replicate the entire thing, but I think that hopefully there could be a few items of interest there. I find that it's been a very fun endeavor, really. And in my world, I can say that having a sand pit where you're only kind of minimally responsible to external stakeholders is a good thing. As the world gets more and more towards the model of micro accountability, ham radio is still an area where you can do what you want, and I've greatly appreciated that in this project. Uh, so I think we've made something of an impact on the world of LF uh, and the community of LF, and I've been pleased to get the encouragement from many people around the world, and also I hope now to give back a little bit in terms of the uh, feeding some of our techniques and results back into that community. So that's pretty much the summary, I think, of the station. I've put some references here where you can find a little bit more about the VK6 MJM. Also, just for people who would like to go away and start reading immediately, there are a few little links here just for general reading on LF, MF antennas and propagation that um, people might find interesting as a way to dip into the area if you're not already familiar with it. So thank you very much, and I hope that you found at least some elements of the presentation of interest.
Very good. Very good.
Yeah, Peter, that is fantastic. I mean, what you've accomplished there with your point 0.1 or 0.2 FTEs, as you said, is simply amazing.
Yeah,
I,
I have a commercial background in LF and VLF and ELF. I worked for 30 years in the military communications business.
Right, right.
And I had the opportunity to build a 1500 watt Class D, 400 to 500 kilohertz and amplifier and an antenna coupler for a very small antenna on a moving
Yeah.
vehicle.
Yeah. Lots
And
of
it was,
kilovolts, Bob.
yes. Um, but here I used a Class E amplifier
Mm.
with a single FET and till I got I my top loading wires is or you know people say you can't get a bird to fly through that backyard of yours. But but I used a lot of the digital mode. But but there was a fair amount of CW activity too. So that was fun. We'd work on CW and then we'd work on FT. What is it? FT9, I think we were using at the time.
JT9 maybe.
Yeah. Um,
Yeah.
it's been too long, but I've been active in this HamSCI stuff, and you can't divide your time sometimes. What really impressed me though was your statement that you've gotten some other people interested in,
Yeah.
in these modes, and that's I think commendable.
Yeah, I think there were a lot of touch points, even though we're literally on the other side of the earth. Hearing that KPH had received you, because Rob Robinette, one of the principals behind making KPH the receiving site that it is today, is on the call with us tonight. Obviously, whispernet.org and using those databases for research and general interest is quite important to us. But just the perseverance you showed in taking this project from where you began to what you've accomplished, Peter, is really quite something. Do you want to take questions for a couple of minutes, or maybe a few out there in the HamSCI peanut gallery?
Yeah.
Yeah, sure.
This is Ed, N3ED, and I would have a question. Isn't there a manufacturer or a previous manufacturer of transmitter receivers for this frequency from Australia?
Yeah, that's true, Ed. My friend Roger, BK4YB, Yankee Bravo, he he has a spin-off of his I think sensor metrology company that he was producing some transverters, particularly for 475 and 136 kilohertz. I don't believe he's actually producing them anymore. They were uh, very good units, just in the way that Gary mentioned, in terms of getting, I think maybe it was Bob mentioned, getting more people into the game. He sold a lot of his 50-watt transverters, and particularly people, Roger from the east coast of Australia and several other stations from the east coast, and quite a few US stations worked quite a bit of DX with those transverters. So unfortunately, the manufacturers sort of come and go a bit in this field, and Roger hasn't told me specifically why he stopped manufacturing them, but he has said that he doesn't see himself starting again. So yes, there were some commercial alternatives. They did have their challenges. Just really things evolve, and stability requirements and things like that evolve, Ed. So they were challenged a bit on the longer duration digital modes with things like stability in the fixed oscillators and so forth. But yes, they were very, very good units that you could show someone and say, well, look, if you want a transverter style operation, this is a way of getting on the low frequency bands for sure.
I see
Yeah, I-
I'm sorry, I was gonna jump to David, the N1 HAC real quick, Bob, and we'll catch you next, is that okay?
Fine.
this
Sounds
is
good.
David, N1 HAC. I got a couple of questions about your antenna system. One is I noticed that your multi-tap coupling transformer is what I would think of as a fairly small core, and maybe not the mix that I would expect, you showed it as an FT140-43. Does that really take the 100 watts at that frequency?
I think actually, David, you're probably looking at the one I showed as the conceptual, from the German guy as the conceptual form here. No, we that would be fine at MF probably. My transformers would be 77 material generally.
Okay, that makes more sense.
And typically for the couple of 100 watts, the 240-77 is
Okay,
fine. And
that makes a lot more sense. The other is,
yes,
so on the other hand, your loading coil, you're using an air core coil.
yes.
Is there a reason you don't use a toroid there?
Yes. It's really just to keep the Q up and any saturation effects down, David.
Right.
People have used dust cores and ferrites and iron cores or other sorts for loading, but it's it needs a pretty careful design if you're not going to saturate. And also there are a few subtleties involved. I mean, actually, I have done it myself in a test system in the backyard here, but there are a few little things like the temperature coefficient of permeability and so on.
I suppose the temperature coefficient is an issue if you have a limited range with the variometer.
Yes, and you tend to think you're only looking at a few hundred hertz shift,
right.
And it is a bit touchy. Yes.
Very good. Thank you.
The Q, if I can just add to Peter's comments here, the Q of an air core that's designed properly, and that means spending a lot of time designing it, and N6LF has written a very good discussion of how to build a high Q coil for these frequencies. But you can really not get the Qs with cores. Now, cores are great to get you into the 200-300 realm with a small amount of wire and everything, but when you really want to squeeze every last micro ohm of resistance in the core or in the coil out of a coil, you want to stick with air. It's very low loss, and you want to keep as much as the material out. But the other thing is the variometer is such a lovely way to go with your fine tuning of the antenna. And you can't do that with a core.
Yes, I think some of the commercial guys, Nortel, for example, their form of the variometer involved some ferrite progressively inserted into an air core. But I looked at that and thought, no, I can't replicate the Q that I can get with the Air Corps. And in fact, I could have perhaps mentioned that there are some nice optimization programs around now for Air Corps inductors, and you can do pretty good models of the inductors with I think it's the coil program. I think it's K6 STI, Brian Beasley, and also there are a couple of the axial mode calculators online that do a pretty good job at getting you in the ballpark. They'll at least show you Brian's coil program, for example, has an optimizer, and it will get you in the ballpark for things like turn spacing and so on. That takes quite a lot of work out of the graph reading and so on.
That's amazing, the scale at which those things operate. Bob, WB0VGD, you had a question?
Yeah, thank you, Gary. And Peter, excellent talk. Very interesting. I remember putting a W6 LVP loop active antenna in my yard, and I was amazed what I could pick up on the 630 meter band. I could usually, during the winter, I could pick up a dozen stations at night, as far south as Mexico and as far east as Pennsylvania and California. So I could cover quite a bit of the United States. I was curious, do you do two-way contacts with the FST modes, or are you operating more in a beacon capacity?
No, I have done some two-way, Bob. Only VK though. Although of course Australia is about 3,500 kilometers wide, and a bit of diagonal. It's easy to get to get some DX all on this continent. So yes, I've done the FST 4W 300. I know that some of the very keen DX people do the 15 and 30-minute contacts, and with the new coupler, I might give that a try. One of the interesting truths that you have to come to grips with on this band, I found, is the extremely non-reciprocal propagation, east-west versus west-east, and at some point you run out of reciprocity. And Australia, the width of Australia is not far off that, I think, because there's no, if I want to talk to, say, Roger in Queensland or somewhere, there's not much point me waiting until his signal is excellent with me, or him waiting until my signal is excellent with him. We've got to work at the OK mark, and it's fine. We can do, say, JT9 or FST modes. But the problem is, as you go much further, it's very, very asymmetrical. And the propagation theory puts it in terms of, very, very complex formulations of the respective refractive indices in the ionosphere. But I don't, for example, think that Western Australia to the US would be a very easy thing, except perhaps under the most unusual conditions. But that's the point, I suppose, of being there a lot of the time, to catch the unusual conditions. But typically the just the common darkness limits, and then on top of that, the non-reciprocal paths make the extreme DX for two-way rather challenging, I think, Bob.
Yeah, when you get below the gyromagnetic frequency, things are a lot different than they are when you're up in the shortwave range. It's really interesting propagation.
Yes.
By the way, Peter, when I look at the polar plot of Australia from here, it's about a 90-degree range, west coast to east coast, and it's all straight. It's all straight north from you guys.
Yeah. Well, the other little thing I've been playing with in my head is the antipodal focusing business, because the antipodal point for Perth, for example, is the Bahamas, roughly speaking. And there was a very interesting experiment actually done in the early 60s by some people in Perth and some stations in the Bahamas with 7 megahertz experiments, and they did in fact find that antipodal focusing has some effect. But there are paths, of course, that through the US that look pretty good for some of those experiments. And I do. I mentioned I got some new spots from stations in the US last week with the 900-second mode, and that was fantastic. Generally speaking, though, they lie on what I'm jokingly called the magic arc, the same arc that connects KM5SW in New Mexico, our shortwave listener friend in Texas. The new stations are all on the same path, and of course, there's a real paucity of data, so there's no point getting too excited. But you do look at it and think, yeah, that's a bit interesting.
Yeah, another point of interest is that we actually have receiving systems at South Pole that go down to 100 kilohertz.
Right,
You should
right.
probably look for your transmitter.
That would be very interesting, actually. I do see South Pole decodes, but unfortunately they're all spurious. So it's just that the nature of the JT database and so on. But yeah, that would be fantastic.
We do have a listening station DP0 GVN, which is listening on 2200 meters and 630. So that's the German Antarctic station. So
I see.
Unfortunately, yeah, all of the Whisper Demon sites, Whisper Demon Grape and other Whisper Demon sites that are contributing to grapes are listening because the RX AAA costs nothing to listen to the other bands in terms of CPU. And so I set them all to listen to 2200 and 630 on all the FT modes through 1800.
Right.
But there's a problem in the RX AAA that we've only realized late, the last few months that deafens them, especially on 2200 meters. So I mentioned in the chat that we will be going through as we deploy and revise those stations. We're going to be taking out the bias T inductor that produces that problem.
I see.
So
right.
you may find that, for example, at KPH, that's on a Marconi T. It's a 300 meter, for 40 meter higher Marconi T. It should be picking you up all the time, but probably isn't because and your presentation has now encouraged me. There's a Kiwi on that, and the Kiwi does work well down to 20 kilohertz. So I'll probably put a 2200 meter listener on the Kiwi as a result of your presentation to see
fantastic.
how much we can improve the signal strength, your detection of your transmissions. Well, how often are you transmitting 4W and such?
Yeah, I should have mentioned that, Rob, and thank you very much for that those comments. I try and do it every night, local time here. So I start just before sunset, and then I go at least through until midnight. And on the nights that the weather conditions are stable, I'd go right through until dawn. So it's as I said, it's not continuous operation. The antenna, truthfully, isn't well behaved enough for that. I think getting rid of the faulty coil, the Litz coil, will go a long way. But the next thing we really have to tackle, probably in the spring, is the radial field. We have to find out why there's more variation than there should be really in the antenna tuning with weather and so on. And I think if we could knock that over, we could actually look at continuous operation.
Well, the Whisper Demon sites are listening continuously, so on all the modes and all the bands. So, but until I get the AAAs fixed at these sites, we have three good West Coast sites that should be able to receive you. KFS doesn't have a. I'm sorry, that can't because of antenna problems. But KPH has that Marconi T, and which is working marvelously. It's actually a good antenna. And there's a K4RBE up in near Seattle in Washington State.
Right.
A beverage, but it needs to have. I'll have to have its AAA fixed. That probably can happen soon. So hopefully we'll be able to give more reports. Although I see, I just did a quick search on. You're familiar with Whisper.rocks? That
Yes. Yeah. Yeah.
yeah. So Phil's. I looked at Phil's site for the last 4 weeks, and yeah, there's I don't know. I had 123 2,200 meter spots there. So that's from you. So let's see what
Right.
happens.
Yeah. Well, one
Uh,
of the things I found, Bob, just in a similar vein, is that the it has encouraged a lot of the Kiwi owners around Australia to improve local conditions. They're, as you say, they're quite capable receivers, but a lot of the local installations left a bit to be desired in terms of choice of power supplies and RFI quietness and so on. So just very gradually, there's a little bit of a shift to say, oh well, maybe we should put a little bit of extra effort in and make the thing actually usable at 2,200 meters.
yeah, we've been working. There's looking into the antennas for the HamSCI Daisy 2 deployment, and one of the candidates is a vertical active dipole,
Right. Yes.
which has is sensitive down to, I don't know, kilohertz, and has tremendous common mode noise immunity. I mean,
Right.
tremendous, 80, 90 dB because of its active transmission from the antenna. And we see, so hopefully now that I know you're on air, I'll make sure that those antennas on the East Coast and elsewhere, we're going to put one in at next week. In fact, at Nathaniel, W2NAF, we're going to put one of those in. So we'll be sure to look for your signals. Maybe they make them to Pennsylvania. That antenna is very, very sensitive.
Yeah,
And
that would be great.
And if you know others who are suffering with RFI problems with their Kiwis, we have about 7 years of experience of working with the Kiwis and
Right.
and at LF frequencies. So we'd be happy to share that information. There's some web pages and a long dialogue going on, and we're happy to consult.
That would be well worth pointing people to, I think.
Yeah, well, there is a groups.io and a HamSCI antenna groups.io, not as active as it should be, but you can do remarkably well even in urban environments if you you've been fortunate, it sounds like, that you have a very quiet site for a monopole receiver, but they're very, very, very difficult to install and maintain at most sites. The monopoles are really subject to lots of local RFI, and mostly it's ground loop injection mechanisms, not radiated. The noise and low frequency for receivers, the noise and reception almost as always is dominated by noise introduced by the power supplies and the ground loops and so on. So
yeah, that's been my observation, Robert. It is interesting though that our US record holder, the Ray SWLEM3 in Texas, he uses one of the small E-probe antennas, but again he has quite a low noise environment, so it's a lot to do with the site. In my urban location here, I need an active loop to get rid of some local interference. So we do what we must, but I do hear a little bit of MFDX on that, KH6 and so on occasionally. but generally nothing of interest beyond monitoring, as I'm legally obliged to do, VK6MJM. But it does it well. So yeah, the immersion in noise and then being our own worst enemies from ground conduction currents and so forth. It's all quite a challenge.
Well, it's great. I wanted to let you know that your signals will now turn our attention toward receiving you. Well,
Thank you.
so you get keep your eye on Whisper.live for more spots.
Thank you.
Well, fantastic. Obviously, Peter, your presentation is enjoyed by everyone. I think the recording will get a lot of play too, going forward. And it's really rewarding to me to hear folks like Rob and others hopefully sort of combine efforts with you to improve the knowledge of the LF band.
Yeah, thank you, Gary. And I hope that I can listen more to some of the people in your world who are working more actively in propagation in the radio science area. And hopefully there's a bit of a synergy going on there.
Well, it's funny. I just started reading a book by Bill Bryson. Of course, anecdotally, he wrote quite a good book about living down under many years ago.
Yes.
But his latest book is on the Royal Society. So
Right. Yes.
I've always enjoyed the history of science and technology and stuff. But the fact that the scientific community, such as yourself, will do so much to share share our findings and share our research, but also to do something like you've done. You're never quite sure what's going to come of it. I mean, you just put it out there and hope for the best, and quite often so much good comes of it. As opposed to many people in this world who are so transactional. If they do A, they want to receive B reciprocally, and it's like it doesn't always work, So
yes, I did my PhD. Well, one of my mentors was Bill Ellis, GRA Ellis in the ionospheric literature, and he had a saying that you have to cast your bread upon the water. And I've never really forgotten that. It can be a frustrating thing if you happen to be a project engineer and constrained by modern system engineering and so on that we all go through. But casting your bread upon the water is not such a bad thing to do.
Fantastic. Well, I'll let you go. Again, thank you so much because, like I said, I think a lot of people appreciated what you had to say, and with these recordings being on YouTube, they'll get a lot of value for a long time coming. I will say that one of our attendees today, I think she signed off, was Dr. Mary Lou West. She's a professor emerita at Montclair State in New Jersey. And her interests are in not only mathematics, but also astronomy and astrophysics. And she says, boy, do you think we could get Peter to talk about pulsars in general someday? I said, well, we'll ask and we'll see how our next season of the HamSCIence call works out with his schedule. So
I might have to get some of my younger and more clued in colleagues there and give a crash course or something.
So, but anyhow, so it's interesting how these things tend to multiply, though. They really do. So the force multipliers are there.
Yeah.
All right. Well, I think we'll end the recording and end the call. Thank you again very much, especially considering the time difference and whatnot. It was an excellent presentation, and people did learn a lot, I'm sure. So.
Well, thank you very much, Gary, for the invitation, and thank you all for your attention this afternoon.
World Amateur Radio Day is coming up tomorrow. That just reminded me too.
Yes.
And how many hobbies can you have? A playground that extends from the kilohertz up to the terahertz. We're very, very fortunate. So pick your bands. All right. Thanks again, everyone. Have a good week. So long.
Bye, everyone.
73.
7-3.